converting from similarity ratios, which are a length ratio, to area ratios. So let me start with this idea. If you want to convert from inches to feet, there are 12 inches in a foot. So actually, I guess you'd be dividing by 12 to do this. Okay. If you want to go centimeters to meters, you got to divide by 100. Now those are lengths: inches, feet, centimeters, meters. If you're going from feet squared to inches squared, well, if you're going to go from feet to inches, that would be multiplying by 12. But from feet squared to inches squared, you multiply by 12 squared, which is 144. Not by 12, by 144. One way to look at it is if you got a foot here and a foot here, 12 squares and 12 squares, well, overall there's 144 of these little squares in the big square. If you want to go from yards cubed to feet cubed, well, there's 3 feet in a yard, so that means there are 3 cubed feet in a yard cube, so you'd be multiplying by 27. We're going to deal with the squaring idea, though. Later in chapter 10, we'll get to the volumes, which is the cube. So if you have 2 triangles that are similar, this has got a length 2, this has got a length 3, these corresponding sides. Similarity ratio is 2 to 3. The ratio of these 2 areas would be 4 to 9. If, on the other hand, this was 4 to 5, this length ratio, which is also called similarity ratio, it would be 16 to 25. Here's some more examples. Okay. In this case, we have some squares that are similar, and so the area, the ratio of the perimeters is 4 to 5 because perimeter is just a length. To get the ratio of the areas, it's 4 squared to 5 squared, so 16 over 25. Here you're given area ratio, so it's 8 over 32, that's area, which is the same as 1/4, and we want to go to a length ratio, or similarity ratio, and you have to, instead of squaring, this time we're taking a square root. So it's going to be the square root of 1 over the square root of 4, which is 1/2. Over here it's 128 pi to 18 pi. Again, these are areas. So when we divide these things, the pi's cancel. 128 over 18, that will reduce to 64 over 9. And then to get a similarity ratio, it's square root again. So rad 64 over rad 9 is 8/3 is our similarity ratio. Now once we have those ratios, we can do a few things with them. So in this situation, we've got these 2 triangles. Okay. Length ratio, 12 over 5, leads to an area ratio of 144 over 25. So now this is just a ratio. The actual area of the smaller figure is 20. And you're trying to find the area of the bigger one. We'll just call that A. And so we can cross multiply or cancel in some way. I'll just cancel here, so I get a 4 here and a 5 here. And so I end up getting that A is equal to 4 times 144 over 5. I have to reduce that. For number 10, let's see, the 7 is not going to help me out here. So I compare the 5 and the 8. So 5 over 8, which goes to 25 over 64. The smaller area is 18 over A. And then again, cross multiply and solve for A. Now for 11, for each pair of similar figures, find the ratio of the perimeters. Okay, you're given an area ratio, so 12 over 27. And we can reduce that first by dividing by 3, and we get 4 over 9. Now if you want to go from an area ratio to a perimeter ratio, which is a length ratio, you take a square root, so we end up getting 2/3. So one more example, back up to, let's look at number 9. Again, the idea here is you set up your length ratio, so 7 over 15. This is the little one over the big one. And that becomes 49 over 225 for area. The smaller area is 84, and the bigger area we don't know. So we would have to solve that proportion. 49 over 225 is equal to 84 over A.